Hi, my name's Doug, and we're coming to you from the outskirts of Louisville, Kentucky. We're going to be able to show you tonight live views through our 11-inch RASA telescope of the Emerald Hills skies. And so welcome. This is kind of an impromptu telescope viewing session because I'm really hoping to practice some new workflow with our planetarium software, which we use the Starry Night Pro Plus. And so we really didn't promote this as a regular live stream like we sometimes do because, to be honest, it's kind of a working live stream. We're kind of experimenting with this, so we didn't want to put anybody through any agony if it takes us a while to get things set up. I will share with you just a little bit. We're using a new scope cam tonight, a scope cam that is not dependent on Wi-Fi, and I'm really glad because it's hooked into the very software and hardware that we use to bring in the images from the scope itself. So we don't have to rely on Wi-Fi anymore and this WISE 3 surveillance camera. Instead, this is a different camera. It's kind of a USB camera that we hope will give us a better view. And you can see the picture's not quite as pretty with the color and all, but we think it'll be a lot more reliable. So that's going to give you a scope view. And then you've also got a view of the sky. This is through a ZWO ASI2600MC Astro specific camera that has the special all sky lens on it. I think we're getting probably I don't know what it is exactly, 150-degree view of the sky. If you look way over to the left there, you can see the bright moon that's about at 50%, that's still hung there above the horizon, kind of flooding the night sky with its moonlight. But we don't mind that tonight. This is more of a workflow night anyway. So you'll be able to see views through the sky. And that particular camera rides on top of this RASA telescope. So if you can see the telescope, the optical tube assembly is the white part there. It's an 11-inch optical tube assembly. That black shade on the front is actually to try to reduce the amount of dew that gets caught on the corrector plate, which is on the front of the scope. And we use that dew shield to try to block the dew from forming there. But if you look above that black dew shield, you can see that red little bitty camera that's riding on the front of that equipment plate. Now, I like this equipment plate, and it's really working out well for us. See if I can get you a closer shot of that. You can see at the front there, there's the red ASI 178 monochrome camera that's going to give you these lovely sky views. There's a picture of what you're seeing through that camera, and that's live. And then this is on top of here, it's the Pegasus-Astro Powerbox Micro. And then underneath it, it's the Pegasus-Astro USB control hub. And man, I'm loving these two blue little boxes, little pieces of equipment that are working in all kinds of temperatures. I mean, we've had them out when it's been just 6 or 7 degrees, and they've purred along with no problem at all. They also give us really good temperature readouts now. I'm looking at our temperature readout, and it looks like we're let's see, I'll give you an exact temperature, 38.7 tonight. Not as cold, 38.7 degrees, and it tells you exactly how much voltage it's pumping into the equipment. 13.7 right now. We try to keep it somewhere above 13, but below 14. And it tells you how many amps it's pumping through. We have about 1.7 amps pumping through. Some of that is the dew strip, the dew strips that are warming up that 178 mono camera that's at the front of that equipment plate. And there's another dew strip around the RASA itself. And then all of this signal is flowing through a rig rack that's at the bottom of the tripod. In fact, I'll show you here that scope cam again, and this is a live view. Over there at the bottom right, you might be able to see kind of a yellow equipment box, and then on top of that is a rack, a little equipment rack. And that Gator equipment rack that you see is this rack that you're seeing a close-up there, a picture of it. And you can see on the bottom floor of that rack is a trip light. It's an AC110 protected power strip unit that's there. It's equivalent to one rack space unit. And that's filtering the AC to make sure it's carefully monitored, and being good to the scope. And then in the floor right above the trip light AC unit, you see a rig runner power distribution for 12 volt power. And that 12 volts is coming from the 12 volt power supply that's just to the left of the rig runner unit. And then on the top floor there, you can see the device that converts all of the data from the telescope, and also for the 178 Skyview camera. It converts that into fiber optic signal, and we run it inside of the building where I'm sitting, and that way I can come to you here in shirt sleeve weather, and we have another decoder inside of the building here on my desk, and it converts it back from fiber back into signal and runs it into our computer here. So it's about 200 feet that we are outside where the scope is there. And the scope is sitting on the concrete pad that is there as a base for the observatory when we get ready to build the observatory. And hopefully that's going to be about 1 month from now that we'll be able to put that observatory up. And by the way, Papa Tech, I see you've logged on from down in Florida. I was just explaining that this is completely impromptu session because we're kind of working on some workflow tonight for to experiment with something in Starry Night Pro. So it's kind of an impromptu session, but it's nice of you to pop in. I think that's what you were asking. What's that white stuff on the ground? That's the concrete pad for the observatory, and it's thick. I mean, it's probably a 12-inch thick concrete pad that's ready, 10 by 10 foot for that observatory, and then a 4-foot front porch there in front of it. So anyway, that's a quick little rundown of the equipment that we're using. And what we want to try to do now is we want to try to go to the live view of the sky. And see, I think we're ready for that. So just work here off the screen for a minute. By the way, if you can see my picture, I'm over here to the right. And right below me, I think you can see a picture of the telescope. And below that, a picture of the sky. So you'll be able to see that along the right-hand side of your picture. But the view here in the middle is actually a live view through an ASI, a ZWO ASI2600MC Pro. It does look like snow. You're right, Papa Tech. Larry, you are on there from Phoenix. How in the world did you find us? I didn't even mention to anybody that we were going to be on, and you must have gotten an alert from YouTube or something. But whatever the reason, thanks for joining us. I've just been sharing a little bit about our workflow. We're going to try tonight a new workflow in Starry Night Pro. And let's leave our live view through this color astro-specific camera, one-shot color camera. And let's go over to Starry Night Pro, which is our planetarium software. I've been communicating some with the makers of the software. And I tell you what, I'm just going to be really straight with you. I was really wishing that there was a way in this software to see a little bit more about the objects that we were observing. And I just couldn't figure it out. And I went through the manual one page at a time. And I thought, surely if I go over here and let's say I look at the different observing lists that I've got loaded, and I imported these from the live sky. By the way, let's bring up live sky while we're thinking about it here. Just going to open that up. And the live sky is really a great idea. It's a web version of the I guess you could say the observing lists and the observations and the sessions that you're using, for observing. So it's really a great idea, and it is actually made by the SimCur people, Simulation Curriculum. They are now the makers of not only Starry Night Pro, but also Sky Safari. So the stuff that we do in Starry Night Pro actually gets linked here to Live Sky, and it acts as a kind of a switchboard go-between so that it also updates what's happening in Sky Safari if you use that on your phone. So it's a really great idea. But I investigated this Live Sky product a lot, and I've also been looking around here in Starry Night Pro a lot, and I thought, surely if I take one of these lists, and it doesn't matter what one we look at, let's just consider something here like, I'll tell you what, I've never looked at this 111 objects for light polluted skies. So let's open that up a little bit. And of course, the first thing that Starry Night Pro does, it scans through all the objects that are in this observing list. And as you can see, it's 111 different objects. It scans through all of them. And I had seen before that just over there to the right, it lets you see kind of a, well, I said it would be over there to the right, but it's not really coming. How can I do that? There we go. It's over there to the right. It shows you how many degrees those objects are above the horizon. I thought that's pretty handy. And yet I had never really investigated this right search, this finder screen for observing lists. And in communicating with one of the SimCur technicians this past week, he said, well, you can actually pull that bar over. And I think this might be undocumented. I couldn't find this in the manual. And even after he told me about it, I went through the Sky guide, whatever you want to call it, the manual for this. And man, look at the treasure trove of information here. What we're basically seeing is the height, the altitude above the horizon that each of these objects is right now. And it's computed real time based on the time that you've got programmed up here in the upper left. And sure enough, I've got February 8th, and it's 11:46 p.m. Eastern time. So it's real time. You notice I've got my exact location programmed in to the 1,000th of a latitude and longitude, 216 meters above sea level. So with all that stuff rooted in, you can now, Papa Tech says not seeing the list. Let me see what you're looking at here. Are you still, I see you're not seeing, why is that? Let's figure out why that's not showing up. The screen, it should be showing you the display. Let's take a minute and work that out because we got to get that figured out. What in the world? I see this screen is oversized because my 4K monitor here. Papa Tech, I'm really glad that you were there to point that out to us. There we go. Okay, now let's get back. That should let you see a little bit more of that list. I know that we've got some things in the way. We've got my picture and the telescope and the sky. But over there on the right now, I think you can see at least the top of it, the list and the altitude above the horizon. Look what else it's got. It's got as he started telling me about this, I thought, oh my goodness, I've never even seen this before. And then he said, you can configure that list the way you want. Just right click on the top bar. This is not documented in the instruction, I don't think. Maybe it is, but I can't find it in the manual for Starry Night Pro. But you can pick what you want. So you notice I've got, for some reason, orbit is checked. And I don't need to see the orbit. Altitude, and then look at this, log entries. Now this is where the problem comes in. You see this column right here? That is supposed to tell you, like there's supposed to be a little symbol there, if you've got log entries for a particular object. Like look here, if I right click on Andromeda Galaxy and show info, look at the times I've observed the Andromeda Galaxy. And by contrast, if I go to something that I haven't gone and looked at before, let's say, well, here's a double star, and I've just never gone and looked at double stars much. So there are no log entries for this double star, what is it? I guess HIP9640, Gamma Andromedae. You know, I've never gone and looked at that double star before, but in this column, which is supposed to be for a symbol for whether or not there have been observations, that column's not showing up. And so we made a video of that and shared it with the SimCrew people. And you know what? They looked at it and they said, oh my goodness, you're right. That column is broken. Now, nobody knows when that column stopped working. The SimCrew people just assumed it was still working. I wonder if it stopped working when they did a change in the database they use for Starry Night Pro. What they did is they used the same database that Sky Safari uses so that they could do live sky and be able to pull these objects together. But when that happened, that's my theory anyway, this column broke. And no longer are you able to see when you observe something. Now, I don't know how long it'll take them to fix that. They now have the work order, you might say, you know, the request to fix this column. And I think they'll make it a priority, but that could take like a month or 2 months or 3 months for them to fix that. So tonight, now that I know this is not possible to tell whether or not you've got observations of a particular object, we've got to come up with a better workflow for the time being. So this is a temporary way to fix this, I hope. And then once they get this working, we'll do a new version of this video and we'll celebrate the fact that that column is there. Now, look at what else they've got. You can choose magnification. I guess that's a prediction of what kind of magnification you ought to use for that object. Shadow cones, local path, and then there's something called hide. I don't know what that is. I guess if you've got an animal skin of that object. No, I don't think that's what it is. I think somehow you're supposed to be able to click something and then hide that object, I assume, which would be handy. Once you've observed something, maybe you will be able to click this and hide it. But right now, the hide column is broken as well. Look, there's nothing that goes on when you click those. So I'm going to go ahead and get rid of the hide column because it's not working. Then it says celestial path. I guess that's like some new age thing. Who knows? No, I think that shows what path it's on in the universe. I'm not sure, but we don't need it because it's not working. So now the only thing we've got left here is the altitude and the log entries. Now I'm going to leave that log entry column because I want to see that the moment they fix it. I mean, I am hot to trot to try to get that log column in there. That's what we really need. Say, for instance, when we're doing the Messier marathon, we want to be able to see when we've logged an observation on a particular object, but it's not happening. Now, the next column you can see is, it says, well, look, there's some other things. Azimuth, which would be what? Your compass point, you know, degrees, so to speak, and then magnitude, how bright the object is. Angular size would be good. If that were available, angular size. Oh, here we go. Yeah, that's really handy because that'll show us how big the object is in the night sky. So for instance, Andromeda Galaxy is 3 degrees. I know that's a good object for the RASA because the RASA can see all that width. But let's say it's something is only like, you know, 3 arc seconds wide, you know, or 2 arc minutes wide. It's going to be a very small object for the RASA. We can still go look at it, but it's going to be very small in our field of view. So let's keep that angular size column up there. And then kind, that's a signal that you're supposed to be really nice to people. No, that's not. We're getting confused here. Kind is telling you what kind of object you'd be going in to look at. Like, is it a double star? Is it a spiral galaxy? Is it a nebula? So that's what kind is. Now look what you can choose next. You can choose semi-major axis. I guess that's got something to do with how it rotates and revolves. You can choose the what constellation it's in, which is pretty significant, but I think we'll leave that out for now just because I'm trying to keep this right-hand panel as small as we can. We've already chosen several things. And then database would tell you which database that Starry Night Pro is pulling the data from. Again, that's interesting, but it's not probably something we need while observing. But look at the next three. We can see the moment that it rises, the moment that it transits, which is when it passes directly overhead, which is the ideal time to observe it. The atmosphere is thinner, whereas if you're looking across the atmosphere, at something low on the horizon, of course, that you're getting a lot more atmospheric disturbance because you're looking at maybe 2 or 3 thicknesses of the atmosphere by going across all that air. So you want to observe the object, if possible, when it's directly overhead as much as possible. You can't always do that. Like in a Messier marathon, you just have to take the object when you can get it. But those are very interesting to see the rise time and the transit time and the set time. And then the right ascension would be interesting to show you how it relates to the right ascension and the declination for an equatorial mount, which is what we're using on our iOptron Sim 70G mount that we're using for this RASA tonight. And then the percent illumination is an estimate of what would be the brightness of the object. I suppose, like for instance, with the moon, it would say 50% illuminated tonight, something like that, because the moon's about half illuminated. It wouldn't be present for every object, and then an estimate of the distance for the objects where there's a known distance. So let's pull this out now and configure this so you can kind of get a picture of what this looks like. I'm going to leave that observed column in there, even though it's broken, because I'm really interested in getting that to work. And we're going to crunch the size down. We're going to crunch the kind, and then make these 3 columns of rise, transit, and set as small as they can get. And then the distance tells you how many light years or how far away it is, or if it's unknown, it's telling us that. I really like this, the way this finder panel doubles as your observing list. And who knew that this did this? I don't think it's in the guide. At least if it's in there, there's not a picture of it that helps you envision it. I guarantee you that, because I'm now looking at every picture in the manual and this picture does not occur. So I'm super excited about this. It does take up a bit of space, and I know that's a bit of a sacrifice, but you can kind of tuck it over there when you're not using it. And then I trust, let's see what it's like. Oh, when you pull it back, you have to configure it all over again, don't you? Well, it kind of all comes out together. When you grab that second column, it all comes out together. So we can live with that. Now, let's talk about workflow. Since the column is broken that has the little symbol in it for whether or not you've observed something, that's broken. So I was trying to figure out how could we jury rig a workflow to help us get by with this. Now, remember, we've got this live sky, website that can help us. And let me show you what I mean. If we go to observing lists here, the same observing lists that we have in Starry Night Pro are uploaded, and it's almost real time. I mean, it's not exactly real time, but it does communicate really fast over to live sky. And this is you can see my little picture up there. This is my, my registration at live sky. So nobody else has a live sky panel that looks exactly like this. And look what we've got. We're on the 111 objects for light polluted skies. So sure enough, that list is in here. We can click into it and look, it's the very same list. Andromeda Galaxy, Andromeda Galaxy. Sculptor Galaxy, Sculptor Galaxy. Acrid is not there. Messier is there. Almach is there. Double cluster is there. So in general, these are corresponding one to the other. And I don't know why the acrid variable and double, I'm not seeing it over there. I don't know if you are, but I'm not seeing it. Now, here's what I think the folks at SimCurve wish. I think they kind of wish that you could alphabetize or arrange. I mean, what am I searching for? The word sort? Yeah, sort. I think they wish you could sort the objects in the live sky panel by clicking the header. But see, it doesn't work. You can't sort them. Now, what you can do is you can say, show us all the objects. And once you click that show on all, and by the way, Live Sky is free. If you buy Starry Night Pro, you get Live Sky for free. It's really a pretty cool deal. And it's a real-time website. Now, notice it says total observed in the entire list, and it says 0. And that's just not correct. You saw my observations for Andromeda Galaxy. So there's something broken about this too. And I did turn this into them, and I noticed they've already submitted a work order to work on that as well. It does show you that you've got 107 entries here. Now, that's probably true because even though it says 111 objects for light polluted sky, look up here at the top. Over here to the right, ZWO is unrecognized. It couldn't find it. And there must be another 2 or 3 that are like that. So we have a fairly good likeness. Now look what I'm doing here. I'm going to say edit. And what this does is it shows you the same list, except now we're in edit mode. And the thought occurred to me, this might come in really handy. Because look, we now have a thing to remove them. And over here in Starry Night Pro, there is no command to remove an object from a list. So track with me here. I'm starting to kind of brainstorm about a workflow. And this is real time, you know. So I've not ever tried this before. We're really going to do this real time and see if it works. But if we keep this Live Sky on edit mode, then notice we can click this and be able to remove them. Now I've tried doing add target and it pushes you down to their Sky Safari web. It's just too much trouble. You can't add targets in the, I'll show you so you see what I mean. It says, oh, you can't do that. To add a target, you have to go over here to Sky Safari on the web. And it's just, by the time you do that, you've wasted too much time. So it's just not worth it to add a target here. That button up there is a little bit deceptive, isn't it? Add target. Oh, wait, you can't do that. With deep respect to SimCur, it's right now, it just doesn't work. But let's leave it in edit mode because I think we're going to be able to use this remove thing. Now let's go back to Starry Night Pro and let's do what we normally would do. We go up here to our sessions and we'd start a new observing session. So notice we're ready for observing session 49. And you can pan down through here and look at all the observing sessions I've done over the past, basically what? 13 months, roughly. I mean, maybe 13 months and a couple of weeks, 13 and a half months. I've had 48 sessions so far. So let's do a new one. And I guess you just click here, 0049 is what we're ready for. And we're going to call it, the title we gave this tonight was February Eve. And the site is, of course, Emerald Hills. Everything's at Emerald Hills that we do. And the date is February 9th. That's because it just passed midnight here, Eastern time. And it's got the time. For the end date, it'll still be February 9th. And the end time, we don't know yet. But let's just guess that it's going to be something like 3 a.m. or something like that. In the comments, I'm going to say, tonight we did an impromptu session to sort out our new proposed workflow for Starry Night Pro in view of the fact that we don't know how long it will take SimCur to repair the observed column. And the, what are we going to call this? The Finder panel observation list. Whatever you want to call that thing over at the right. That column is broken. So what we're working on here is a workflow that we're going to try to propose. Now we've started our session, so we can now get rid of that panel. Now notice up here also there is an observing list applet, but this is not very helpful because if you click on 111 objects for light polluted skies and you edit it, notice when I click on the name column, you should be able to sort it. in name, and you can't. It doesn't work. So here are 111 objects that are in random order, and you can't find the thing you're looking for with deep respect to SimCur. I think this is broken too. So we've communicated this, and the SimCur people have said it's broken, and they've put a work order in to fix that as well. All these things broke, I think, when they probably synced and changed their observation list data with the Sky Safari data. That's the theory that I have. Again, you should be able to sort. I would think you would want to sort by type. And look, here is a beautiful column for whether or not you've observed the object. It's just that it doesn't work. You saw that I have lots of observations of Andromeda galaxies. Those rascals are not giving me credit for my observations. So the observation column just doesn't work right now. And this actually goes along with the fact that the observation column is also broken in this finder panel on the right. So the point I'm trying to make is this little observing list box that we've got here in the middle, it's not very helpful. I'm sorry. Right now, it's not. But I got the idea. What if we created a working copy of the 111 objects for light polluted skies list? So I'll show you what I mean. You can create a working copy. Now I'm going to say from list. And when you click the from list button, it makes a new copy of those 111 objects for light polluted skies. And let's see what it calls it here. I'm not seeing it. Now here's the original one. 111 objects for light polluted skies. Maybe I have to click that and then click add to my data. I think that's what we have to do. So let's try it. Okay, so we have this original one. Now let's go down to the bottom. Yeah. So see, we've got an exact copy of it. So it's wild, isn't it, that you can have two observation lists with exactly the same name. How is that possible? Let's change the name of the one we just made. Like, doesn't matter which one because they should be identical because I didn't mess with the original one. I've just looked at it, viewed it. So let's edit it and change the name. Let's say 111 objects. Now I'm wondering, are we going to be able to see the whole name? No, look, over here it gets cut off a little bit. So let's go 111 objects, and then let's put in brackets working copy for light polluted skies. And I think that'll help us distinguish. Now let's click OK on that. Now let's go over here to our new, notice that the way we get to this, and let me erase this for a second, you'll see there's the original search list. But if you put in here, if you put the word lists, for instance, not losts, but lists, it helps you find anything in your database in Starry Night Pro. In the whole Starry Night Pro database, stars, galaxies galore. It finds all the things that you've got entered that are lists. And the only thing we have that are lists are the observing lists. So look, here's the original one, 111 objects for light polluted skies, and here's the working copy. So now I'm thinking, let's open up this working copy. Wait, let's do one other thing before we open it up. I'm thinking that once we observe something, we note that by adding it to another list. I know I'm reaching here, but stick with me. I think I'm just kind of brainstorming, but this has never been done. This is actually live TV. First time this has been done, as far as I know, anywhere in the whole universe. Let's open up those observation lists again, and let's make a new list, and let's call it 111 objects observed. Now this list needs to be empty because presumably we're going to go through this list now and observe everything. So the name is 111 objects, square bracket, observed for light polluted skies. And let's click OK on that and OK on that. Now we've got our working copy and our observed. Now notice the observed copy is empty. So what we're going to do is once we observe something, we're going to add it to the working copy. No, sorry. In the working copy, once we observe something, we're going to add it to the observed copy. And then as soon as we do, we're going to try to go over here to our editing list. But we got to make sure we're working on the right list. Let's cancel out of this because the one we want to work on, let's go back to observing lists. Now notice how quickly they populated, they uploaded to, because right now this is like a website. This is not in Starry Night Pro. This is a SimCur deployed website that you get to use for free. And notice it's already populated the working copy we made and the one we just made called observed. And it shows you got 107 objects in the working copy and 0 in the observed copy. And those are correct. We have 0 in the observed copy. So let's go to the working copy and let's open that up and let's get in edit mode. Now we're ready here. We won't have to ever change to the observed mode in SimCur Live Sky. So let's leave Live Sky for a second. Let's go back over here to Starry Night Pro. Let's connect our telescope. Man, I hope this works. I should have connected the telescope first before we did all this. Rats, what if it crashes? Boy, brace with me here for a second. If we connect the telescope and something crashes, I'm going to feel bad. Let's try it. Oh, we're connected. Okay, good. So we're going to click OK. So our telescope now is connected to our planetarium software. Let's call up our working copy of the 111 objects for light polluted skies. Notice it's scanning through and it's trying to determine the altitude and the observability, the availability for all these objects. It's going to tell you the ones that are like the Sculptor galaxies already below the horizon. And we know that for sure because look over here. It's set at 8:51 p.m. Now I wonder if we use this title, 111 objects working copy or something like it. Let's close this up and let's put in the word working. Yeah. See, I like this better because now we're not wasting the space at the top of the column for those other lists. But what happened to our column entries? How about that? Ah, look at this. Look how interesting. We don't have our column entry now. Why is that? You know, all those fancy columns we had, they're gone. What? Okay, so if we put in lists and we look at working copy here, that stuff is up there. But if we close it and if we put 111 objects and we open up the working copy here, we don't get our columns. That's a shame, isn't it? What a bummer. Okay, we'll just have to use the original. That's what I'm saying. It's live TV, folks. We'll have to use the original deal and use the lists. And then let's open this up. Now, I'm going to look for a second on the screen and see how much of this list you're seeing. You're actually seeing quite a bit of it now because our picture and the telescope and the sky are kind of over to the right. But what I'm noticing is you're not able to see all the other data. So here's what I think I'll do. I think I'll go over here for a second. And I'm going to pull these down a little bit. That's what I'll do. I'll just make these smaller. It's probably more important that you see the example of the data. Especially it's more important than seeing me. Okay, so now you'll be able to see, I think that'll remember that. So now you're able to see a little bit of the data here at the top. Okay, you with me? Okay, so let's make this as small as we can make it. Okay. All right, so are we ready to start our workflow and experiment? We're all set. Let's go to the Andromeda Galaxy. Well, first, let's decide the order we're going to go in. Now, we can sort these. Let's say we want to go in order by height above the horizon, altitude. Look at that. In one mouse click, it sorted it in height above the horizon. So I like that. Let's go to whatever 48 Cancri is. What is that? It's a double star. You know, I've never done many double stars, but let's do it just because we're trying to get through. So let's start observing and do a bunch of observations and experiment with our workflow. Ready? Okay, so slew to 48 Cancri. Now you should be able to see the scope actually moving. I am going to say center on that object, and that'll take our planetarium software over there, and it'll show us approximately in the sky where are we. So we're right at the meridian, and sure enough, that's pretty accurate. And notice that it's showing that the telescope is just now arriving. So we beat the telescope there when we went in the planetarium software. So that's good. Let's zoom in a little bit, and I can use my wheel here on my mouse. I love this. And we're going to see this double star here, and it is 48 Cancri. So that's what we're trying to see is this double star. Will we be able to split it with our RASA? That's the question. Ooh, it's a pretty close double. Let's go back over to SharpCap and looking live through our, and let's do a plate solve because this is our first target of the night. Remember how I've told you before, the way we set up the telescope is we polar align the mount on the tripod. So that's just aligning our physical tripod so that the axis of the tripod is looking at the night sky. Then we polar align, and we're off 3.85 degrees because it's the first target of the night, and that's just normal. Why is that? Because we're not aligning the mount with the sky at all. We're just aligning, we're aligning the mount with the polar axis. We're not letting the computer know, look, it's already splitting this double. I love this. Okay, so we did sync the mount to this, and now we're going to put a name here, and the name is, oh, look. Because we've got so much data now, I can't see it off there to the right. So I'm going to pull this over. I know that's reducing the size, but I think it's important so we can move quickly here. 48 Cancri. What is that? Cancer? Is that what that is? I hope we don't get cancer just by observing this. That's the name. Now let's zoom in. And there's the double. Sure enough, it is an interesting double, isn't it? Look at the bigger star. It's got almost a, I'm colorblind, but that's not colorblind, but color deficient. That's almost like got a, somebody tell us what the cast is. I think it's like yellowish, reddish, something like that. And then this almost has a blue cast, doesn't it? So that's very interesting. Let's go here to 48 Cancri. And let's say new observation, and we have to associate it with, now here's a question, do we associate this with the working copy? I don't think we do. I think we associate it with the real copy, because the working copy, you'll see what I mean, it's going to disappear over time as we remove things from it. So let's say add that. The observing session, notice how it did that automatically. We didn't have to associate it. Why was that? Because it figured out we're in the middle of this time slot, so it automatically knew. Down here, we'll just pick our telescope assembly, and I hope we don't have to do that every time. And here, a lot of times on our first observation, there's a weird thing that happens with the notes section, but I'm going to try here. We were able, yeah, look, that's all I can type is we were. So I've reported this to the people at SimCur, and so far they really haven't responded on this one. I don't think they believe me yet. But people at SimCur, if you're watching this, this is all I can type in this note field. But watch, if I select this text, copy to the clipboard, erase this entry, delete log entry, delete. Now add a new entry, paste my old text, now I can type. Whoops, I spoke too soon. I'm going to delete this one too. Delete log entry, delete. Try another one. We were, boy, I had my caps key on or something. We were able, now I can type more. So it restricts the amount of typing I can do in the notes. Now, I don't know if that means that nobody's using this observation functionality, and for that reason, nobody's reported it to SimCur, but there is a bug in this observation applet, and I'm hoping, SimCur, that you can put this on the list. It's only a minor irritant. We had to delete the first two this time. And once I get in a rhythm, it doesn't seem like that happens very often. It does every once in a while, but not as often. We were able to split the double. The larger object, the larger star, what would you call that? I'm sure there's a name of it. We'll look at that name in a minute. The larger star had a, what tinge? Yellow, red tinge, maybe. And the smaller element had, right, a bluer tinge. So since we deleted the first two, we have to associate this with that again. And we also notice that it's associated with the February Eve correctly, and we're going to associate it with our rig, the RASA 11 with the 2600. So our observation is done, and the only thing I wanted to look at is what are the two elements? Oh my goodness, look at all this. Iota Cancri, 48 Cancri, almost due north of the Beehive Cluster, the Chrysope, and the 4-star box that makes up the manger of Cancer, the crab, lies Cancer's second brightest star, rather oddly given the Greek letter iota, showing that Bayer had more in mind than brightness when he ordered the constellation stars. The brightness order going beta, iota, delta, alpha. That's not the order of the Greek alphabet. What? B-I-D-A. So let's remember that. Beta. Iota Cancri's mid-4th magnitude, second best, is a bit of a cheat, however, since the star is a double, which makes it a mere 1/100th of the magnitude, about 1% brighter than Delta Cancri. Beta, iota, delta. The two stars looking exactly the same brightness as seen with the human eye. To be perfectly correct, the star should be known as iota 1, notably dimmer than iota 2, lying a couple degrees to the northeast, but iota will serve here. Iota Cancer, is that right? Is a classic and pure example of a wide binary consisting of a 7th magnitude white class A, and we could see that it was blue-white, see? It's a white class A with a 4th magnitude yellow-white class G. Now, see, we didn't even have to read the description before we could detect that. And I guess it's because I'm red-green colorblind. I could see that yellow-orange, yellow-white. It is 4th magnitude. Remember that a 4th magnitude is brighter than a 7th magnitude because the magnitude numbers are in reverse order, with 4 being brighter than 7. I don't know why they did that. Though the colors of the star do not differ by all that much, contrast effects caused early observers to declare them clear blue and pale orange, making them a fine sight and a small telescope, low power, enhancing the contrast. Neither of the stars is well studied. Parallax measures of Iota Cancer B seem to show it much closer than the 300 light-year distance of Cancer A. Let's put this over here to the right for a second. Let's go back to our Starry Night, and then we can be looking at these as we talk about them. So the bigger one is fourth magnitude yellow-white, class G. That one's called Iota B. No. The blue-white one is Iota B, and the yellow-orange one is Iota A. Anyway, I've never done very many double stars. This might be my first double star in history. So I'm really loving this. You know, a lot of people split doubles for all of their observing. They get a big kick out of this. I've never done this before. Anyway, this is 48, however you say that word. Does it pronounce it for us? Cancri? I don't think it pronounces it. Nope. No audio. 48 Cancri. That's my story, and I'm sticking to it. We got our observation. We're going to close this window now. And here's what I'm thinking we do. We right-click this, 48 Cancri, and we say, add to an observing list. And we, you might not be able to, yeah, I think you can see the edge of this. We're going to right-click, add to observing list, 111 objects observed. So now that observing list has one object, one target in it. But 48 Cancri is still here in the working list. So now we go over to Live Sky. And we find 48 Cancri. And that's sad because who knows where it is, because we can't sort this in any way, can we? Is it in order by, well, there goes my workflow down the drain, huh? What? Let's cancel out of this. We are in, but if I search for 48 Cancri, oh my goodness, they can't even find it. Unless in this database, which is Sky Safari's database, it might be known as HR 2948. And to check that, let's go back over to Starry Night Pro, show info. I'm not seeing it. I'm not seeing it. That identifier is not here. What in the world? Good night. Been a long day. Thanks for stopping by, Papa Tech. I don't blame you for not staying. This is a workflow night. Somehow we have to be able to remove this from the list so we can tell what we observed. But the problem is, it's not on there by that name. But when we search for, oh, the 48 found HR 2948. That's why I found it. Oh my goodness. You know what, SimCur folks, if you are watching this, this search box apparently doesn't work either. Sadly. It's searching 107 total entries and not finding this object unless we can search for it under a different name. Let's search for it by iota Cancri. Let's try that, because this is the Flamsteed number. Maybe that's not in the Sky Safari data. Maybe. Let's search for HIP 43103. HIP, not there. Let's search for it in iota. Ah, that found it. So aside from the little runaround, we have to look for it under the different name. Simker people, that's irritating. So now we're going to go back to edit mode. And we're going to show all entries, and I'm going to do Control F. No, wait, I'm going to use this search. CANCN iota Cancri. There it is. And we're going to remove it. Delete it. It's gone. Now here's the thing. It'll take it a few minutes to populate back to Starry Night Pro. But since we've deleted it here in the Live Sky side, now it's going to remove it from our working copy list, and that will vanish. Now, I'm not sure what we have to do to make it vanish here. For example, let's go search for something else. Let's search for, iota Cancri or whatever. Now let's search for lists again and go to the working copy. And it's gone. Well, maybe not, because we put it in order of altitude. Yeah, there, it's gone. So see, when we deleted it from the working copy in Simker's Live Sky webpage, it is a two-way synchronization. Now, another thing I thought we might do, if it didn't do it quickly enough, look what you can do. You can go up here and say, sync with cloud now. And when you click that, it forces a sync in case it hasn't synced. But we don't have to do that sync with cloud now because it was that fast. Now, there is the minor annoyance that it won't get rid of it because it's sorted on your screen and it's leaving it there until it's kind of like the way a web page does. You call up the web page and maybe some web designer changes the text while we're reading it, but the whole time we're reading that web page, we still get to read it. And it's not till we refresh the web page that we can see the changes that the person made. So we had to refresh this list before we saw that it was gone. But I don't think that's a big problem, because the typical way that we would work is we would sort by altitude and we just go down the altitude list. And we'll get as far down as we can in one night. Let's say we go through 13 targets in one night, or in a really effective night, 20 targets in 2 hours, let's say. If we just are setting records, 20 targets in 2 hours. When we come back next time, it will have had plenty of time to synchronize, and we'll know exactly where to start again on our list. So let's try a couple more objects just to make sure we're comfortable with this workflow. Let me just make sure we didn't start a live stack here, but let's save a picture of this. Snapshot, and it's going to save it according to this name, 48 Cancri, for whatever that's worth, because you can't use that in Live Sky. Now we're ready to change. Now notice we didn't have to live stack that data to see these stars because they were bright enough. And part of that's just having a fast telescope. The RASA is f2.2. It's a very fast telescope. So we're able to see this real time. 3 seconds is all the longer we're shooting these exposures at 400 gain. So it's really working well for us. Thank you, RASA. Next object. let's go to NGC, which is a spiral galaxy. It's only 12 minutes wide, but let's go look at it. So we're just going to say slew there. And let's go back here and back off to auto. Now, hopefully you're seeing down below me, the telescope's moving, and you're also seeing in the way bottom right-hand corner, in the tiny little corner, you're seeing the sky change as well. You can see that in the ASI2600 frame, we have it on 3-second time exposures. So it's moving fast enough that these all look like satellite trails, because as the camera's moving, it's capturing a star and then raking it across the night sky because it's slewing to the next target. Now this NGC 2903 is a spiral galaxy. It's at 72 degrees above the horizon. Let's center on that in our planetarium software, and that'll let us read about it. But while we're here, let's plate solve again. Remember, we try to plate solve at least our first 3 targets, and that way we can see how accurate we're getting on our mount. So hopefully it'll find this array of stars in its database, and it did. And it found that we were just 1/4 of a degree off. It's a second target. And as we go through each target, each one will get better and better, and finally we don't have to plate solve anymore. So that's the way the plate solving helps us. So now we plate solved, and I think I can already see a smudge there in the middle. So let's change the name, and the new name is NGC 2903. And with that, let's go to our sequencer and change to start imaging. That'll change our exposure to 20 seconds. You guys who've been with me before, you'll remember these settings. We do 20-second exposures often with a gain of 100 with this camera. This ASI2600MC Pro loves the 100 gain. It gives it a dynamic range of like 15 f-stops, really huge dynamic range. Let's get rid of that box, and let's do let me reset this display histogram. Just reset that to make sure that's, oh my goodness, that is weird. I'm not going to try to arrange that histogram. I'm just going to reset it. And then let's reset this color balance. And that's a little better. A little bit bluer than blue, don't you think? Bluer than blue. Redder than red. Don't ask me why that's so red. Greener than green. Boy. You know, I don't know how far this is from the sun, from the moon, but I bet it's fairly close. Let's, since that's live stacking, anyway, let's go over here to our planetarium software. Have I told you before that when you're alt-tabbing back to Starry Night Pro, it doesn't behave? And I've reported this to SimCareer, and they say, yes, it's a known problem. It's too much trouble to fix it. So what you have to do is minimize the window in front of Starry Night Pro, and then it works fine. But you can't alt-tab to it, really. Let's back off this until we can figure out where is the moon in relation to this. And will we be able to see the moon? Oh, yeah. I'm kind of getting a picture. The moon. Wow. Moon is not very close. So what time does the moon set? I don't want to go search for it because we'll get off of our list. But let me just look at my phone here so we can leave this version. What I'm going to do is open up Sky Safari Pro, the companion, and I'm going to say search for the moon. And it sets at 2:14, so it's still very, very visible. So let's center on the moon. Ah, I see where it is. Okay, so it is playing havoc with our image here, but I think we can get along with it. It's funny we don't see it here, huh? It's just not. We need to make, oh, there it is, the moon. So let's look at the angular degree, angular separation with where our telescope is. So I changed the hand to the angular degree, and it's 81 degrees, but it is still wreaking havoc. Although it's 81 degrees away in the angular separation, it is still causing all kinds of problems. Sorry to say. Now let's sit on this object again and magnify. And it's going to zoom in now. This is Starry Night Pro. This is planetarium software. But it's going to zoom in, and we'll see if it has an image of this galaxy. And it does. It's a nice image. It's not quite face on, but still pretty well face on. You can see, we ought to be able to see eventually an arm here throwing out gas and dust and stardust, and an arm here. And then notice there are several stars that are being born in this nebulosity here along the outside, all this gas and dust. And look at that bright core and probably a black hole in the middle there. This is a beautiful galaxy. Although it is small inside of our RASA field of view. This red rectangular represents the RASA field of view. Okay, let's go see what we can do with it here. Oh my goodness, it's kind of nice in the middle. Now, do you notice this donut here? By the way, if you're curious, we are using darks and flats. But I'll tell you what this is. This is the fact that the moon is bright. And the second thing, it is that we have our histogram out of alignment here. And the third thing is, I'm just going to do true confessions. Our RASA is not perfectly aligned for an object like this on a moonlit night. It kind of reveals the fact that we've still got some work to do on our RASA. This has to do with the camera alignment with the light path of the scope. We got it fairly close. I think we're within something like, we're within 30% of the correct back focus, and we're within, I forget, 23% of the correct, you know, what you would say, the actual tilt of the camera in relationship to the mirror. But it was getting colder in the fall, and to be honest, I just wanted to get started observing. So once it gets warmer weather and I can stand out there for 6 hours, because that's what it takes. You have to work for about 6 hours to get this aligned properly. Don't buy, this is live, yes. Plenty C and IG, this is real live. Thanks, Plenty, for checking in. I don't know where you're logging on from, but it's good to see you here. Anyway, it takes about 6 hours. Don't buy a RASA unless you're willing to stand out there by the scope and work for hours to get rid of the mirror tilt, the camera tilt, and get the correct back focus. Like I say, I got within what I consider to be an acceptable range, you know, for most of the work that we do. But when the moon is out and when the object is small and we're cheating a lot on our white balance so we can see the object in moonlight, that moon is just casting moon glow. What is the moon at tonight? Somebody tell us. Is it 50%? What is the percentage of what is the percentage of, what do we call that? The percentage of luminosity of the moon, 62% tonight. So that's a lot. I mean, a lot of people, they want to observe on the new moon, don't they? With our Emerald Hill skies, we don't care. we observe when the moon is full. We just accept the fact that we're going to have to do some careful tuning. So let's get started. Let's start with the best view that we can, which is not this. Wow, look how green that is. Let's pull down the green a little bit. Boy. Oh, looky there. At least we're going to see the structure, even if it is going to be in Martian green light. We're not viewing this through Mars Martian lens. This is 8 minutes, and look how we've been able to stack the structure of this galaxy. Although I'll admit the color balance is wacko. I'm trying to work with it here. It's a challenging moonlight target. Oh, look, it's coming along now, right? Looky there, it's coming along. How about that? Okay, so let's pull these blacks over a little bit. Oh, that starts to get rid of some of our structure, though, doesn't it? I'm going to hold down the Shift key and pull this over with the Shift key down. That lets me make a finer tuned change. Now, see, that's too much. We want to be able to preserve those arms. Now, to take a really good picture of this, we would want to be on a moonless night, and we would want to integration of this object would be like minimum 3 hours. And then we could see this. But remember the view that we looked at in Starry Night Pro. What we were trying to find is this arm here and this arm here. And we wanted to see some of these stars that were being born, and we wanted to see that bright core. Everything we wanted to see in the structure, we're seeing in just 9 minutes and 40 seconds. So let's do a picture of this. We're going to save exactly a scene. And I also like sometimes, this is NGC2903, I like just taking a quick screen capture of this because it makes it so big when we just do the screen capture. And then down here in the lower right, I'll label this and we'll say, we'll call it NGC, oh, now I forget the name, 2903 was it? Oh, I can look over there to the right, 2903. And we're going to say 9 minutes. And then we'll say 2022 on February 9th. And then we're going to throw in the name Doug. Trying to get in the habit of doing that for our Messier marathon coming up. And we want to put this under desktop sharp cap captures. Now it should be there with the other image we saved. Now we can go to the next target sequence. Next target sequence, and that changes our exposure back to 3 seconds. So now we're all done in SharpCap for our workflow. We can go back to Starry Night Pro, and we've now observed NGC 2903. So let's add our observation. Look, it looks like we observed this on March 6th. Can't believe Messier missed this. Must have been the lights in Paris. We could clearly see the bar as well as both inner spiral arms and way outer spiral arms. So amazing that it's 30 million light years away. I love that. Must have been a moonless night. We're going to say, in spite of, what was it? 60, I forget. We'll say 60%. 60% moon light. We could still make out both arm structures and even the baby stars along with the dust lanes, those darker dust lanes we could see. Notice that it kept our observing list and our February Eve. Now the telltale sign, did it keep our equipment? It did. So it keeps your equipment as long as you're in the same session, because it assumes that you're in the same session. Now we've observed that object. Now it's tempting just to check it, isn't it? But this checkbox is not to say, check, I observed this. All that checkbox does is it turns on the name and makes it so that it's labeled. And we have it labeled with our extra labeling that we've configured in Starry Night Pro. But if the person didn't have labeling configured like we do, then when you check this, it would at least label it for you. So that checkbox has nothing to do with observing. And because of this column being missing in action, it does not illuminate with that little symbol. So again, what we're doing with this new workflow is we're saying, add this object to observing list, observed, 111 objects observed. And then, remember it's NGC 2903. Now we're going to go back over to Live Sky, get my bearings here. How did we search? Pray tell. Where's the search box? Now here it is here, 2903. So there is the galaxy. Can we remove it here? Yes, we can. Save. How is that doing that? Evidently, after it sits idle for a while here at Live Sky, since it's in edit mode, it must somehow refresh. And when it refreshes, it's taking away the search box. So again, in terms of workflow, I hit save. The search box was there. We searched. We could still remove. So we didn't leave edit mode ever. Huh. So in terms of workflow, this is working, although I'm not quite sure how. I noticed the building heating is off, so I'm going to grab my little heater here and sort of supplement the heat, because even though I'm inside, it has to be getting down to, like, of all things, like 68. So I'm getting a little bit cold. Now outside, it's what? We can tell you exactly what it is, can't we? Right here, it's 38 outside. See how this works? 38 degrees, 38.8. This is our Pegasus Astro Pocket Powerbox Micro that's sitting on top of the scope. And I showed you this at the beginning. It's this, that little outrigger equipment plate. That's the box, that's the smaller box that's sitting on top there, the smaller blue box. So that's how we're seeing this little power applet, because this applet is connected to that box, which is super cool and lets us see the temperature. The dew point's 28, and it's activating the dew strap heaters so that the dew doesn't form on the corrector box. I just love that. All right, so now if we were to refresh like we did a while ago, NGC 2903 would disappear, but I'm just going to check it for right now. And we're going to go to the Beehive cluster. And remember, we already configured Sharp Cap for the next object. So we're just going to slew to it right away here. While that's slewing, we're going to back off a little. And hopefully in these lower panes, you can see it sleuthing. Let's go over to Sharp Cap, and man, you know, it's just like interstate highway here, isn't it? So again, in the screen that you're seeing, you can see the telescope moving immediately below me. And then you can also see below that the ZWO ASI2600MC, which is riding on top of the scope. Remember, it is right here. It's that little red camera that's on the front of the equipment plate. So you're able to see what is happening because of that little camera. Now let's come back here to the live view. And remember, we are still at 100%. So let's back off to auto and change the name right away before we forget. This is Beehive Cluster. I kind of wish we had the other name for it, because I don't like to use the words if I can get along without them. M44 is what we want to say. We don't want to say Beehive Cluster. We want to say M44. So now that's ready for plate solving. Remember, we try to plate solve our first 3 targets. And each one gets a little bit better. I think we were off like, what? I forget. A couple degrees on the first one, I forget. We were off, what was it, 1/4 of a degree, I forget, or 2 degrees on the second one. This one's off 0.23 degrees. So now we're at 23 hundredths of a degree. And by the time we get to the 4th target, if we plate solve there, it'll be minuscule. So the mount model improves with each subsequent search. Wow, this is a great cluster, isn't it? But the stars are so scattered. It almost doesn't look like a cluster, huh? We don't have to plate solve this. Let's darken this a little, in fact. And let's do that by reducing the gain in this case. Let's bring that gain down to 200 and see if we can make that sky a little bit darker. That's a little bit better, but look how wide this cluster is. Look how scattered it is, you know. It's incredibly wide, isn't it? These are 3-second exposures. Look at these stars over here. Isn't that funny? Those look so crazy similar. Let me zoom in on that so you can see that. I'm going to try to find them here on the zoomed in screen. Yeah, look at that. How crazy is that, that it happens that those stars are big one, little one, big one, little one, side by side like that. Let's go over to our planetarium software. Remember, you can't Alt-Tab to it. You have to minimize the window in front of it. And let's zoom in. And we're still an angle of separation till we go to adaptive again. But I'm trying to think where those 2 double stars would be, or whatever those are. Oh, you know what? We haven't gone to the beehive yet. Sorry. Center on the beehive. And let's just go there quickly. If you hit the space bar, it just jumps right there. Now let's zero in, zoom in. Here they are. Look at them. Sure enough, it's just 2 stars. Tycho 1395, 2321, and Tycho 1395, 2311, Tycho 1395. So these are all 1395. So that must mean they're like within the same cluster. Wow, look. These are not double stars, but this one is a double star. See that? Now you might be wondering, why is that? Why is that traveling? It's because we've not locked on to this cluster yet. So we would need to like lock to it in order to There. Now they should stay put. So let's go back over to SharpCap, and I'm just curious. We're at 100% already. If we go to 300%, does it let us split that one star? No. That's just a little bit too close. We're at 100% here, and doesn't look like we have the capability to split that. Anyway, let's take a look at this cluster, and then let's read about it. Beehive cluster, show info, description. The famous Beehive cluster was described by Galileo. It has been known since antiquity. It is easily visible to the unaided eye as a faint round patch of luminosity. In binoculars, it resembles a swarm of bees, giving rise to its popular name. The cluster contains many double stars. We saw one. The beehive is best seen in binoculars and telescopes low power. The cluster occupies 1.2 degrees of sky and is set against a region of low star density, making it stand out even more. The cluster is of several hundred stars, may share a common origin with the Hyades cluster. Very interesting. We've looked at this on December 23rd, 2020. Amazing. Must be hundreds of twinkling stars. And also January 11th of 2022. That was just last month. Wow, it really does look like a swarm of bees. We could clearly see a couple of hundred stars and even spotted what we think are some of the doubles. I bet that was not a moonlit night. So let's do a new observation. We can just do that from right here and say the moonlight cast a slight colored tinge on the beehive tonight. 60% moonlight. Still, we could make out the 100 or so stars. Continued on our workflow with Starry Night Pro and the workaround for the broken observed column. So just a little bit about what we were doing. Kind of just record what happened. Notice if we did have this checked, it's not checked anymore. But that's okay. This beehive cluster is nice, isn't it? Although it's pretty loose. It's an open cluster. And all these stars are traveling together. Probably share maybe a common point of origin. Maybe newer than the globular clusters that are like the old standbys. These open clusters are basically just kinship. You know, these stars are kindred spirits traveling together. Maybe they've picked up a few of these stars along the way. Anyway, now let's go add this to observed. And in SharpCap, we don't need to do really a picture of this because that's not a really great picture anyway. And let's go to this, and it did. Look, it refreshed, and it took away our search box when it refreshed. So we can say, I guess, save, and it put the search box back for a moment, and then it disappeared again. We can hit cancel, but the search box is here. So let's try beehive, and there it is. Now we're not in edit mode anymore. We must have taken too long. Now we're in edit mode, and the search box is there, so we can say beehive and say remove, delete. We're removing it from the working copy. We save. So that's the workflow. And now we're ready to begin a new target. All right, so let's sum up what happened. We shared with you these extra columns that I had certainly never seen before, and maybe you're a Starry Night Pro user. Maybe you're well accustomed to seeing all these columns. Hats off to you, because I can't find them in the guide, in the manual. It's called User's Guide. I can't find them in the user guide myself, at least a picture of them, and I couldn't locate them in any of the text that I could find. We can configure these by going up here and right-clicking. We can pick the columns that we want, like that. Then we can sort according to the column that we want. So we sorted by altitude, like that. But we can't mark it. We can't tell that we've observed it yet, because this column is broken. Hopefully the SimCur people will fix that. Go SimCur. We still love the program. It's still beautiful. And with this workflow, we now have a way to show what we've seen. Now let's finish by going and looking at the list in which we are showing that. Well, here it is. Observed. Let's say lists and have it refresh, and then say observed. So those are the 3 objects that we've observed so far. And then notice that those objects are no longer present in this working copy, which is our copy that we're using to schedule our observations. See how those 3 things are gone. Oh, I need to sort by altitude. Well, they're not gone yet. For whatever reason, they're still there. Where is the thing that says, oh, look, it's synced with the cloud. Do you think we have to go back to observing lists? Nope, it says 3, and this is dropped to 104. So it will sync eventually, won't it? Lists. Let's search for something else first. Let's search for, beehive. And there it is. Now let's search for lists. And let's go to the working copy. Sort by altitude. Oh, they're still there. Beehive in 2903. Sync with cloud now. It's done a sync sometime. There must be a limitation as to how often it will sync, perhaps. Tell you what let's do to check this. Let's save this under a new SNF file. Let's call it February 9th. Now let's close and reopen. So this will be like, I finished my observations for the night, and I don't want to have to start and wonder, what did I observe in my last session? So just to take away all doubts, we're going to open up that SNF file, because that contains all of our saved values. So it starts us right where we were. Now we're going to sort for lists. We're going to look at our working copy list. We're going to sort by altitude. And now they're gone. 2903 is gone, and the beehive is gone. Admittedly, it's a workaround. But honestly, as an observer, if you're watching this and you're an EAA, Electronically-assisted Astronomy observer, doesn't this work for you? As you go through these objects, you're observing, you finish your night, you close out your file, and next time when you want to start with new targets. This works for me. I can get by with this. It is not as handy as being able to see the observed copy, but it does work. So we're going to share this with SimCur. We're going to share it on the SimCur board, where you can go for, it's like a forum, and it lets you do user support. And I'm starting to share things that I'm finding. You can see several D. Lucases here. And I'm also sending them sometimes private messages with video examples and saying, you guys got to fix this. This is broken. You know, this does not look good. And they're responding. And they're saying, you're right. You know what else we asked them? We asked them for the power to be able to filter this list. We'd like to be able to somehow say here somewhere there ought to be a button that says, you know, well, like you do in Sky Safari. Why should an app on an iPhone be more powerful than what I consider to be the most powerful planetarium software for amateurs and professionals alike on the Windows desktop? It's ludicrous. So sure enough, they admitted, yeah, we need filters. Because look, in Sky Safari, you can say, when I do, what is it, under observations, I can filter is it not under observations? Maybe it's under observing lists. And if I pick the 100, yeah. So what I did is I picked, because our 111 working copy is already in Sky Safari. It's been synchronized through Live Sky, so it's in Sky Safari now, even though we just created it. And I can say, show me all the targets, or I can say, show me just what we've observed, or I can say, show me the unobserved. Now, if I go to the observing list, 111 objects observed, and I put it under show me the things we've observed, it still doesn't work correctly because that observing column is broken. But if that observing column is fixed, we have the filters built in here in Sky Safari. Why should that work in a smartphone app and not in Windows? So they've admitted, they said, yeah, we need to put that filter here, just like we did in Sky Safari. And furthermore, up here in these observe applets for lists and sessions, we need to make that searchable too. There's no way that we should be able to do this on our phone and not be able to do it in, are you guys seeing this? I hope, yeah, you're seeing it, and not be able to do it in Starry Night Pro. So I've preached my sermon and said my piece, and I'm hoping the SimCur people will listen. Do I still like SimCur? Absolutely. Do I think it's the most beautiful planetarium software and the most powerful planetarium software for amateur professional astronomers alike? I mean, look at that Milky Way. Look at those objects that it perfectly positions there in the night sky. Look at the way it allows us to do this photorealistic horizon, you know, and it's real. I mean, tonight I am observing in that building right there. That's the office, and I'm here in this corner office with the light on and there. This is an amazing piece of software. Just a couple of loose ends that if we just shore those up, it'll put a better face forward. And so those folks at SimCur are working on it. When they do, we'll replace this video and show how it works with the new stuff. Thank you for watching this. If you like content like this, I see we've got a few that are watching live, even though this was unadvertised. It was completely impromptu. But if you've watched this live or recorded, we invite you to subscribe and to click thumbs up. It doesn't cost you anything, but it puts it up in the search algorithms that YouTube uses to show it to other folks who love the night sky. And that's a great way to, if you want to be able to have kind of an investment with us in this kind of, live streams. We're not charging anything, of course, and I've already gone on record saying if YouTube ever starts by some weird thing, if they do start giving some kind of, payout for number of observers or something, number of views, we are going to donate that to a nonprofit or something. We're not going to take any of that if it ever happens someday in a land far away. This is not for the money. We won't even use it to buy new astro gear, But if you could hit subscribe and thumbs up, maybe click on that bell so you'll be notified. We'd love that, and we invite you to do that. We're going to end the live stream now, but feel free to stop and look at some of the other videos there in emeraldhillskies.com or on the YouTube channel there, Emerald Hill Skies. Thanks for taking part in this, and God bless your night. May you have working columns for observing in everything you do in life. Okay, thanks and good night from Emerald Hill Skies. Bye.